In this video, we'll be learning about a concept called hybridization. Hybridization will help to explain bonding more effectively and also to explain the shapes of molecules more effectively than theories such as Lewis and Vesper theories. So Lewis and Vesper theories are pretty useful when it comes to predicting molecular geometry. But the problem is they don't give you the detailed information that other theories out there can. And there are also many exceptions to the octet rule that aren't really well explained using Lewis and Vesper theory alone. We just kind of say they can break the rule and that's about it. So when it comes to quantum chemistry, quantum mechanics, we use two different theories for bonding, and one of them is called the valence bond theory and hybridization. They kind of go in hand. And then there's also something called molecular orbital theory to better explain bonding and shapes overall. We're not really going to cover molecular orbital theory. That's something you see later on. For us, we're going to focus on the idea of valence bond theory and hybridization, and I'm going to connect that to Lewis and Vesper afterwards. So here we have a molecule. We have H2 molecule. They're connected to each other. And we see that there's a share of electrons, a covalent bond. And so now let's take a look at what that looks like at a quantum level. Here we have hydrogen. It has a single electron in its valence shell, one electron. And this hydrogen also has one electron in its valence shell. And so when they bond, what's happening is their orbitals, the orbitals in the 1s over here and 1s over here, are overlapping. And that overlap can contain two electrons, just like any box or orbital that we've seen so far. So that's really what's happening during bonding. We have these unpaired electrons in the two separate atoms here, and in regions where they're unpaired, they can overlap with each other and form a bond. And that's really what a bond is. It's an overlap of those different orbitals. And so here we have an overlap of a 1s and a 1s from two different hydrogen, and that contains two electrons with opposite spins, which is kind of interesting. So now we're starting to look at bonding in terms of quantum mechanics using this idea of valence bond theory, as opposed to just using this Vesper or Lewis structure over here. So in valence bond theory, we're going to focus on bonding as really the overlap between atomic orbitals. And when they overlap, that's when you get a bond. So as we mentioned here, we have the two hydrogens that are coming together. They have their single electrons in their 1s orbital, and to bond, they're going to overlap. They're going to meet each other. And so in that overlap region, that's the bond that we have here. We have two electrons. Here we have the molecule hydrogen fluoride, HF. H has one unpaired electron in its shell. And then if you look at fluorine, it has 7 valence electrons, but the one we're interested in is the single p electron in its 2p shell. It's unpaired. And so that one there is going to pair up with the single 1s electron in hydrogen. So they're going to overlap. You have a 1s overlap with the 2p overlap from a fluorine atom, and that leads to the bonding in HF. And then here we have F2. Both fluorine atoms have their individual single electron in the 2p that's unpaired. And so they're going to have an overlap of those two 2p orbitals, and that leads to some bonding over here. So this really is valence bond theory, where we're describing bonding in terms of overlap of the orbital regions where you have these single electrons. Now, when we look at valence bond theory, we really want to focus on overlap being the concept of the bond with some maximum overlap for maximum stability. And we're going to see in some situations that our overlap may not be enough to explain how bonding happens. So we're going to have to throw in another concept in there called hybridization. But for now, we're going to focus on simple valence bond theory, how to represent it, how to draw it. So you can see in this little figure over here that we want to show the bonding between the two hydrogen atoms to make the H2 molecule. And so what we typically do is we'll draw a little energy level diagram to show the arrows involved in the valence shell, the electrons involved in the valence shells of each atom. So we have one arrow up here. And so what's going to happen is that since these are both single arrows, these are the ones that are going to want to bond with each other. They want to get a partner. And so to show the final overlap, we can draw the 1s, both the spheres over here, and we can show the two electrons participating in the bond in the middle. And they have to have opposite spins, just like you would see in a typical orbital diagram. So you can see them with opposite spins here, and you only have two in there. So first you draw out a Lewis structure to see what type of bond is going to form. I draw out a energy diagram for each of the atoms that are going to be present in the bond. Focus on the valence electrons specifically. The single electrons is where you're going to see the ability to overlap. And when they overlap, you want to make sure you pair them with opposite spins. Right now, we can see that we're going to have a linear molecule here because it's simply two atoms connected to each other, just like in Vesper. And so this is essentially this over here. And we have shared pairs only. So try to make those connections there. And again, here we can see the valence bond theory explaining bonding in hydrogen. And we can do this with a variety of different molecules. So we'll do this with HF. So here's a Lewis structure that was drawn first. We have a bond here. And we want to make sure that our diagram basically explains this Lewis structure. So we will draw energy level diagrams for hydrogen and fluorine just side by side there, as you normally would. And what we want to look at is regions where there's single electrons. So we have a single electron here and a single electron there. And so these are the ones that are going to overlap. You're going to have the 1s electron from the hydrogen overlap with the 2p electron over here from the fluorine. And so let's go take a look at what the different parts represent. So the red that I circled here will represent the single electron that's waiting to bond with the electron from hydrogen. And then all the green areas that are circled, what you'll notice is those green areas, they actually correspond to the number of lone pairs that you see on fluorine. So this is a lone pair, this is a lone pair, this is a lone pair in the valence shell. The 2p is the valence shell of fluorine, as you can see there. And again, the red areas circled, they're the parts that are part of the overlap here in the valence bond theory. And there's two electrons in there with opposite spins. And it is a linear molecule because we only have two atoms there, so it's a nice linear molecule. And you can do the same idea with fluorine, the fluorine molecule. So draw out the Lewis structure, draw out the energy level diagrams, do it for both atoms, of course. And the region where there's a single electron is where you'll want the overlap to occur. As you can see with the red circles there. And so this is our overlap region here. I didn't draw everything else in, just the overlap regions from the 2p with the two electrons in there. And then the other parts here, these will be the lone pairs on one fluorine, and these are the lone pairs on the other fluorine. We don't really focus on the 1s here because that's not part of the valence electrons. And so that is valence bond theory in a nutshell. In the next videos, we'll do some more practice problems showing bonding with valence bond theory.